Guys, here's a video to help you with some of the examples from the area practice. This first example you'll see here, clearly it's a triangle, so we know the formula for area of a triangle is 1/2 the base times the height. The problem with this one is they don't actually give us the height. All right, I know some of you might think that the 10 is the height, but unfortunately the height is supposed to be perpendicular to the base. So if 36 is your base here, you know, the 30 and the 6, 36 total, this right here is your actual height. So we don't know that. Well, if you look carefully, obviously this is a right triangle hiding in here. Well, that means this has to be a right angle also, which means we have a right triangle where the leg is 6, the leg here is h, and the hypotenuse is 10. So we actually have to use the Pythagorean theorem to get the height. Alright, so a little bit of side work here to get the other piece of the puzzle to help us get the actual area using Pythagorean theorem here. So this ends up being h squared ends up being 64 if you simplify all that, and then h is 8. So now you have the height is 8. The area of the triangle is 1/2 the base, which again is 30 and the 6 together. 36 times the 8. Clean that up. Ends up being, what is that, 144? And its area, so it's square units. And there's the area of your triangle. Now you could technically do the area of the left-hand triangle and the area of the right-hand triangle and add them together, that's fine, but you still needed the height. Alright? For this example, it's not a shape that we have a formula for, of course, right? This star kind of thing. But there's a triangle, 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 and they're all congruent, right? You see the tick marks. So we have 4 triangles and then 1 square. Well, looks like the square is all 4 by 4. And the triangles here, 4 is the actual base, right? And the height they actually give us. Well, the height for this one's got to be the same as the height for that one, so all I really need to do is the area of a triangle, right? Again, 1/2 base times height, but there's 4 of them. So let's get one of them first. So 1/2 the base, which is 4, times the height, which is 2 square root of 3. Clean that up, ends up being 4 square root of 3 for one triangle. Well, 4 of them would equal 4 times 4 square roots of 3, which is 16 square roots of 3 units squared. So that takes care of the area of the triangles. I still got to add in the area of the square, though. That's the easier part. The area of the square is just 4 times 4, which is 16. So the area of the square plus the area of the 4 triangles, so the total area is going to be 16 plus 16 square root of 3, and that's technically units squared. Alright, so anytime you get a shape that's not like one of the automatic shapes, you know, just a triangle, just a rectangle, just a trapezoid, whatever, just break it up into smaller pieces and then add up those areas. Okay? For this one, they're telling you it's a parallelogram. So if you look at your formula sheet, you know the area of a parallelogram is just base times height. But in this problem, they actually don't have the height. Okay, we know the base, and we know the area. So we have to just work a little bit backwards this time. The area is actually 153. So 153 equals the base, which is 17, times the height, which is x. And then we just solve that the usual way, and you should get, let's see, what's that? Is that 9? Double check here. I think it's 9. 153 divided by 17 is 9, so x ends up being 9. Okay. All right, the next one here. Let's see, what do we got? Can I fit that on there? Yeah, there we go. All right, one diagonal of a rhombus. All right, so first of all, I know I have a rhombus, so I don't know, I'll just try to draw it. And a rhombus, if you remember, all the sides are the same. And that's all we really have so far. So one diagonal of a rhombus, so I'm going to actually draw a diagonal, is 3 times as long as the other diagonal. Okay, so I'm dealing with the diagonals for sure. Now I have no idea either of the lengths of these diagonals. I just know one of them is 3 times bigger than the other. So if one of them is x, let's say, right, let's just say, let's go A, B, C, D. Let's say AC equals x. And I know BD is supposed to be 3 times as long, right? AC is x. I know I didn't draw it to scale, but AC is x and BD is 3 times as long. Well, if AC is x, then BD has to be 3x. Right? 3x would represent the entire length of BD. So it doesn't really matter what you pick. You just have to know that one of them is 3 times bigger than the other. The area is 24 square feet. All right, so we need the formula for area of a rhombus. Well, if you look that up on your formula sheet, you should get the area of the rhombus is 1/2 the product of the diagonals. Now you might ask why I didn't choose to use base times height for this, since it's also a parallelogram. Well, look at all the information they're giving me. They're not giving me anything about the base or height. So all I know are the diagonals and how they relate to each other. So I know for sure the area is 1/2 the product of the diagonals, and one diagonal is 3x, and one diagonal is just x. Cut it off there. So the area is 1/2 times 3x times x. Doesn't really matter which one is 1 or 2. There's still just multiplication. And I know the area is 24, right? 24, they gave me that, 24 square feet. So 24 equals 1/2 times 3x times x. And now it's just a matter of cleaning it up. So 24 equals 1/2. Let's clean this up because I'm sure you're curious. 3x times x is not 4x, right? That's when you add them. 3x times x is 3x squared. All right? The half and the 24, if I multiply both sides by 2, right? Multiply both sides by 2, that'll take care of the 1/2. And then I'll just do it over here. I get 48 equals 3x squared. Well, I'm trying to solve for x, so I got to get the 3 out of there. I got to divide by 3. So that's 16 equals x squared, which means x equals 4. Okay, I'm not going to use the -4 here, of course, because I can't have a negative length. Let's check it. If x is 4, my diagonals would be 4 and 12. Find the area of a rhombus with diagonals 4 and 12. Well, the area is 1/2 the product of the diagonals. 1/2 times 4 is 2, times 12 is 24, and it's square feet. So it works. All right? So for this one, oops, sorry, cut that off. For this one, you just got to make sure you use the information they give you. Label your picture. It's so much easier when you draw a picture, and then it's actually not so bad. A little bit of algebra here, but nothing over the top. All right, last example here. Clearly, we recognize this, hopefully, as a trapezoid. All right, and the area of a trapezoid we know is 1/2 base 1 plus base 2 times the height. So that's just straight from the formula sheet. The problem with this one, again, kind of like the first one we did, is we don't actually know one of the pieces. In this case, we don't actually know the other base. All right, so we have to do just a little bit of work here to figure that out. If we draw in this vertical line here, all right, look what we have. We have a rectangle here, right? Parallel lines with 90-degree angles. So you know you're going to have 90 up here and 90 up here. That's a rectangle. And you have a right triangle hiding on this side. So our goal here is, we know one of the bases is 11, and we know the height is 21. The problem is we just don't know this other base. So all my focus is going to be on what's this little piece and what's this little piece. I'll just call it x and y. Well, if we draw this down here like this and make a rectangle, we should know this part immediately, right? Don't these two parts have to be, don't these two sides have to be the same? So part of the other base is 11, and then the real tricky part is going to be getting this one. So here, let me redraw it. I'm going to redraw this triangle here, 50 degrees, 90 degrees here. If this is 21, this has to be 21, so that's 21, and this is the missing piece. Well, by me drawing it like this, I hope that rings a bell in your head saying, wait a second, a right triangle where I know one side, I need another side, and I know one of the acute angles. Yep, you're right. It's SOHCAHTOA. All right, so I'm looking at that. This is the opposite. This is the adjacent. Well, opposite and adjacent would be tangent. So the tangent of 50 equals opposite over adjacent, and then we solve from here. All right, so we need tangent of 50 from the calculator. I get 1.1918. 1.1918 equals 21 over y. Cross multiply. I get 1.1918y equals 21. So y equals, if I do the division out, 21 divided by 1.1918. I get about 17.6. Let's just leave it there for now. So that's that's the other piece of the base, 17.6. So that's right here. So now my total area, or I should just say area, is going to be 1/2 base 1. Let's just call that one the 11. 11 plus base 2, which is 11 and the 17.6. So that's 28.6 times the height, which was 21. So again, one base, two bases is the whole thing here, 11 and 17.6, and then the height is 21. And now we just, do the arithmetic. But the hard part was getting this other base. So this is going to be 1/2 times 39.6 times 21. A little help from the calculator on this one. So 0.5 is a half. Straighten that up a little bit. 0.5 times 39.6 times 21. And it looks like we get about 415.8 square units. So the reason these are good examples is they don't always just give you all the pieces you need immediately. Those are nice. Those should be easy. But anytime you're missing a piece, you have to do a little bit of detective work to figure out what those missing pieces actually are. All right, hopefully that helps. If you have any other questions, be sure and let me know, and I will see you guys soon.